Hello everybody, welcome to a episode of Sciencing Everything. Today we will be determining how realistic is the maximum wind threshold for the TIV2 in the hit game Twisted. So, first off, the maximum wind speed in-game is 235 miles an hour. My best estimate would be 330 miles an hour is approaching the maximum. So, what are we going to have to find out in order to solve this very difficult equation? So, first, we are going to want to find the exact, basically, we're going to want to replicate a day where a 300 plus tornado did happen in real life. So for that date, I have also liberally picked May 31st, 2013 in Oklahoma City, which is close enough to El Reno. And we can get a guess that humidity is 100%. So I'm being liberal here, and I will subtract 1,000 pounds from the maximum wind threshold. 1,000 pounds from the maximum point of failure. I'm gonna subtract minus 1,000, or I'm just gonna subtract 1,000. And because it's a humid day and the soil is probably gonna be quite wet as well. So what we're gonna want to do here now is first we are going to find the total diameter of the spikes, which I got off Wikipedia, that it is 1.51 inches in width, or about 4 inches in diameter. And plugging it into a calculator I found online, we can get an estimate. Since the spikes go 3 feet into the ground at a 22-degree angle, we can get a pretty rough estimate that the maximum speed threshold is about 11,000 pounds before failure. Now, I'm pretty sure you're saying the spikes would break well before that. You're wrong there. I hate to say it, you're wrong. I did the research. The soil would break well before the spikes would. And the soil would break at about 11,000 pounds per spike. So 11,000 times 4, yada yada yada. Let me get my calculatron out real quick. I know, grown ass dude using a calculator to solve 11 times 4. Equals 44,000. So 44,000. In total, because of course the TIV has 4 spikes, 2 in the front, 2 in the back. And so this right here is our max that we cannot exceed, 44,000 pounds of force. And I subtracted that off of each spike, 1,000, I subtracted 4,000 in total already. Because it was a rainy day, and the spikes will probably be hindered a bit by the moist soil. I know this down here doesn't really make much sense, this whole 20 degrees thing down here. Now, what we're going to do is we're going to find the drag coefficient and the total force caused by the wind resistance. So I'm going to grab a calculator. Well, at least an online calculator of like basic drag coefficients. Or I'm just gonna liberally say that the total shape additive basically rounds out to a trapezoid. And that's being very liberal here. I mean, it doesn't even really look like a trapezoid, but we can round it out to a trapezoid, just being very liberal with, sizes and stuff here. And after that, we can get a total estimate that the drag coefficient be 0.9 of the entire surface area, which is about 350 square feet, being very, very liberal here. How many times have I said liberal? Jeez. So 0.9 drag coefficient across 350 square feet. Now, inputting that to a calculator, we can easily get that the drag generated would be about 42,000 pounds. Now, yes, you can do this on your own and get the answer. I know you can. 42,000 pounds. Now, estimating that my calculations are a bit off, I'm going to say that 330 is the max. 330 is very clearly the maximum here, because it gives us 2,000 pounds to spare, which is about 10% off, 10% air, or about, not about, more like 8% air, but still close enough. And honestly, I don't feel like pushing it. I don't feel like inputting any more numbers and solving any more math. Now, to add on to this, we can also say that there's downforce generated because of the fact that the TIV has angled sides. And now, the downforce generated, which I did some math, but this is not really required since my point has already been proven, we can say that there's at least 23,000 pounds of downforce being applied. Which is about twice the weight of the TIV, or TIV if you're a nerd. Yep, that's my notes right there. So basically, at 330 miles an hour, of crosswinds at least, it would generate 23,000 pounds of downforce. So yeah, it could easily, basically support itself. Why is it not like this in game? There are many possible reasons here. One of them being, if you give people an indestructible car, it's probably not going to be as fun. There's no fun if there's no risk in doing anything. Now, my solution would be to buff the wind speeds, in-game wind speeds, by about 30-ish, so maybe like, actually, no, 275 seems like a fair number. And also, I don't get why it has to be like, like a VIP thing to have anything that can survive 300 plus. The TIV can very clearly withstand 300 mile an hour wind speeds. The spikes wouldn't snap, since the earth would snap well before the spikes do. Well, or like the ground beneath it would like give way well before the TIV does. And yeah, debris might damage it, but it's not like there's actually any debris damage for cars in game. At least the player is not damaged by debris when they're sitting in a car in game. So yeah, it can very easily survive, well, with some struggle, survive 330.